All right, so good morning, and let's talk about the chapter of alternating current and some basic uh, derivation. So now we know that inductors and capacitors both don't consume any real power. What they consume is reactive power. Only resistive circuits consume real power, which is in watts. So let's see the mathematical expression for power consumed by an inductor, and it should come out to be zero in a full cycle. So you have the voltage which is applied to the inductor as V naught sine omega t. The current for an inductor lags the voltage by an amount of 90 degrees. So this is omega t minus 90 degree. Okay. So let's see, if we have to calculate the power comes out to be V naught I naught. I'm just multiplying 1 with 2 with the full knowledge that current lags. So this is sine omega t multiplied by sine of omega t minus 90 degrees. And therefore, this comes out to be V naught I naught sine of omega t multiplied by sine of minus 90 minus omega t is equal to V naught I naught sine of omega t. And just for your knowledge, sine of minus theta is equal to minus sine theta, and sine and cos of minus theta is equal to cos theta. This is also some type of knowledge of trigonometry which you must have. So this becomes multiplied by, I'll use this expression. So this will become minus cos of theta, which is nothing but omega t. So I will just rewrite this as V naught, which is a peak voltage, multiplied by peak current sine omega t into minus cos omega t. Omega is the angular frequency and is written as 2 pi f is equal to 2 pi by t. So this is your instantaneous power being received by the inductor. Okay. If we have to calculate the energy or the power over a cycle, what you have to do is you have to write PT, which is an instantaneous power, multiplied by dt and divided by the time interval. And just for your knowledge, what we're doing is we're calculating the power over one cycle for a sine graph. Okay. So this is your sine, and the current is not a sine but lags by 90 degrees. So this is your V versus T, and the current will be 90 degrees away in its behavior. Okay, so this is a cosine graph. It does not start from zero. A sine graph starts from zero. Cosine graph starts from non-zero value. So let's do this integral calculus over the full cycle, and what we will get is V naught I naught sine omega t cos omega t dt divided by integral of, it's a separate integration, 0 to t, which is a full cycle, or we can also write this as 0 to 2 pi. It's your choice. You're doing it with respect to dt, so write capital T, capital T. And once you do this, what you will find is that this expression, the sine omega t and multiplied by cos omega t, is actually sine theta cos theta. So this expression is sine theta cos theta. And if you see the previous video, you will find that if you sine 2 theta can be written as 2 sine theta cos theta. So let's say you write, and I'll just rub some stuff out of this so that it's easy for us to do the further calculations. And I'll just rub this part and let's see, how we progress into the later part of it, okay? So let's say we had done, V naught, I naught, sine omega t, cos omega t, minus 0 to t, because divided by dt from 0 to t. So this actually, tells you that the 2 sine theta cos theta is sine 2 theta. So you can see this is sine theta, this is cos theta. So this can be written as minus V naught I naught sine 2 theta by 2. So you take the 2 down and you get this answer. And if you integrate it 0 to t, and this is whole divided by 0 to t dt. And if you calculate this, minus V naught I naught by 2 integral of sine 2 theta. Actually, this is sine omega t. So let's not use, so this is omega t dt and 0 to t. We can also write d theta because omega t actually is angle. And if you integrate this and you divide the integral of dt, the dt integral is equal to t. So I'm just writing a t and then I'm writing the upper value and the lower value. If you look into this expression, this is the integration of sine function over a full cycle, okay? And if you do it, you get an answer as 0. See my previous video where sine theta over a full cycle comes out to be 0. And also, by the way, the cosine function over a full cycle also comes out to be 0. So if you write cos theta d theta, it will come out to be 0. So you can see this is sine theta and this is being integrated from 0 to t. So this is 0 divided by t minus 0, the upper limit, and this comes out to be 0. So you can see the power consumed is 0 over a full cycle by an inductor. So this derivation, what you saw till now, was basically for an inductor which is connected to an AC load. Your whole emphasis was to get sine theta cos theta and then use the property that sine 2 theta is equal to 2 sine theta cos theta. And then use this sine theta and cos theta, take 2 on the other side and write it as sine 2 theta by 2. If you integrate sine function, sine 2 theta or any sine function over a full cycle, you always get a 0. So this was a derivation of the average power consumed by the inductor over the full cycle. It comes out to be 0. So that is why inductors are considered to be not consuming any real power. The real power is only consumed by resistors, right? If you have a capacitor, it also consumes no power. But in the case of capacitor, the current leads the voltage. But in the case of an inductor, the current lacks the voltage. I hope this helps. Go through this in detail, take your time. You will be able to understand it. Thank you very much.